Math Blast 15. I can add and subtract multi-digit numbers. Find the sum of 391,472 and 528,940. The sum is the answer to an addition problem. So I'm going to add the numbers. 391,472 plus 528,940. Notice I'm lining up the place values so that I can add like units. I have 2 ones, 11 tens. I'm going to bundle 10 of those tens and turn that into 100. 14 hundreds. We'll leave 4 of the hundreds here, bundle 10 of those hundreds and turn that into 1,000. 10 thousands. There will be no thousands left. We'll take 10 of those thousands and turn them into a 10,000. 12 10,000s. We're going to take 10 of those 10,000s and make it 100,000. And I'm left with 900,000s. 920,412 is the sum, the answer to the addition problem. Find the difference. Now the difference is the answer to a subtraction problem. So find the difference in 265,081 and 184,791. Again, I'm lining up the place values here so that I can subtract like units. 1 from 1 is 0. I'm going to need to do some regrouping here. I start with 8 tens and I want to be able to take 9 tens away. So I'm going to go over here and there's no hundreds. So I'm going to go over to the thousands and I'm going to do some renaming. I will take one of these thousands and turn it into 10 hundreds. And that leaves me 4 in the thousands place. Now I have some hundreds that I can rename into tens. I'll take one of these hundreds, leaving me 9 here, and I'll let 10 tens unbundle. But there was already 8 there, so that's why this is 18. So 18 minus 9 in the tens here is 9 tens. We have 9 hundreds minus 7 hundreds, which is 2 hundreds. 4 thousands minus 4 thousands leaves us with no thousands. 6 10,000s, and we want to take away 8 10,000. So again, we're going to need to do some regrouping here. I'm going to come over to the 100,000s. I'm going to get one of those. That leaves me 1. I'm going to take the 1 that I'm getting there and unbundle it and let 10 10,000s fall out along with the 6 that's already there, and that's why that's 16. So in the 10,000s place, I have 16 minus 8, which is 8 10,000s. And 1 minus 1 is nothing. So we have a difference of 80,290. I can multiply multi-digit numbers by a single digit. 2,415 times 3. I'm going to use a place value chart to model this. We have our thousands, we have our hundreds, we have our tens, and we have our ones here. And I want to start out with 2 in the thousands, 4 in the hundreds, 1 in the tens, and 5 in the ones. And I want 3 groups of that. So if I'm multiplying by 3, that means I'm making 3 copies here. So I have 1 copy right now. Here's my second copy of 2,415. And here's my third copy of 2,415. Now, I'm going to say I have 6. I'm going to start over here in my ones actually, and I'm going to go, hey, I have 15 ones here. So I'm going to actually bundle 10 of these and turn them into a larger unit, a 10. And that leaves me with 5 ones, and now I have 4 tens. And when I look in my hundreds place, I have 12, so I'll bundle up 10 of those, turn those into a larger unit, 1,000, and I was left with 2 hundreds, and there's 7 thousands there. So the product, the answer to my multiplication problem, is 7,245. I can compare fractions. Compare the fractions using greater than, less than, or equal. Explain your thinking. So I have 2/3 and we have 4/10. Now I know that 2/3 is more than half. And I know 4/10 is less than half. So I know that 2/3 is going to have to be more than 4/10. Since 2/3 is more than half and 4/10 is less than half, 2/3 must be greater than 4/10. I can determine the measurement of an unknown angle. Determine the measure of angle ABD. So I'm going to note here I have ABD. We're trying to find this part right here. Now I see that ABC, the whole thing here, is 90 degrees. So I know that I'm going to take that 90 degrees, the whole ABC, and I'm going to subtract 20 degrees because this part is already given. That would tell me what's left for ABD. So angle ABD is 70 degrees. I can identify quadrilaterals. Circle all that apply. A quadrilateral is a four-sided polygon. A trapezoid is a quadrilateral that has at least one pair of parallel sides. So I know here's the at least one pair of parallel sides. They would never touch no matter how far extended. A parallelogram is a quadrilateral that has two pairs of parallel sides. Now we've already shown that there's one pair, but this side is also parallel to this side. So those are never going to touch, meaning we actually have two pairs of parallel sides. So we've now shown that we have a quadrilateral, a trapezoid, and a parallelogram. Now a rectangle has 4 right angles. There are no right angles in this figure, so that's not a rectangle. While a rhombus has 4 equal sides. And it looks like our 4 sides are equal, so we're going to call this a rhombus. To be a square, there would have to be all equal sides and all right angles. And so since it's not a rectangle, it can't be a square. A square, again, would have to be a rectangle and a rhombus. So the most specific name for our quadrilateral here is a rhombus. That's all for today, math friends.